Hi everyone, this is yours truly, Lady May, coming back with part 4 for multiple transformations of the quadratic parent function. We ended with graphing the transformation for the parent function for g of x equals 2x squared minus 5. This is the transformation of that parent function. Now here, number 6, it said how would you transform, that doesn't sound right, this one, stop. How would you transform of the graph, how would you transform the graph of f of x equals x squared to produce the graph of the function h of x equals negative 1/2 x squared plus 4. Okay, so we're comparing that to the parent function here. So here we go. We have, this is the parent function, x squared. This is the parent function. What is being done to that parent function? You probably said, well, Mrs. E, you notice this right here, a is negative. Okay? So if the coefficient is negative, so since it's negative, I know it's going to open downward. Okay? Meaning it's going to reflect over the x-axis. It's going to reflect over the x-axis. Okay? So we know that. Now we're going to say that A is less than 1. It's less than 1, but greater than 0. Because A equals 1/2. So since A equals 1/2, then we know that this is going to be a vertical shrink by a factor of 1/2. Okay. We have all that. Got that done. Bam. Then we have here the lovely plus a 4. The plus 4 tells us it's going to shift up 4 units. It's going to shift up 4 units. Okay. That's number 6. Just going through, identify the parent function, then tells what's happened, tell what's going on based on the previous lesson. You have to read though, guys. You have to read. You have to observe what's going on with those different functions as you graph it. You can't just graph it and think you're done. You have to look and say, oh, what's going on? Okay. Number 7, say use the transformation you described here in 6 to graph the function h of x equals negative 1/2 x squared plus 4. Identify the vertex and the x-symmetry of the parabola. Okay. I'm not going to do that for you. You could do that yourself, okay? Okay. You already have 1/2 x squared. You have this, okay? And you know you're going to flip it. If you just say, well, oh, I don't want to do all the different transformation. Well, baby, it's okay. Just go ahead and make your table value and get your domain and range to graph. Number 8 is how would you transform, this of, it's hurting me. How would you transform the graph of f of x equals x squared, again, the parent function, to produce the graph of the function k of x equals negative 1/2 in parentheses x plus 4 squared. Now, this is a little different because notice that the x squared, you don't have that x squared. You have x plus 4 squared. Okay? So now, this right here, it does make it a little different. This is your A in this case. But some of you, what you probably want to do is distribute this. I wouldn't. Okay. I'm going to tell you guys like this. Since you are Algebra 1 kids, just substitute values in for x and get your information to graph. Then after you get the graph, then compare it to the parent function. So you may not be able to tell every transformation. However, you should say, okay, well, this is negative, then I know it's going to reflect over the x-axis. That you know for sure. Okay. Some of you may say, well, I know that this is between 0 and 1, it's going to be a vertical shrink. Yes, but if it was a coefficient besides 1 on this x, it could change it. Okay. So I would say just make a table of values and graph the equation 09 and then compare and identify the transformation. Okay. Some give you a different information well, different directions at least. Number 10, it says the graph of g of x equals a times x minus h squared plus k represents multiple transformation of the graph of the parent function f of x equals x squared. Okay. Now in this case, well, maybe we wouldn't do it. Look, it's okay, it's okay. As a math person, I'm thinking, it don't have to just be x plus 4. That could be something else in front of that beside 1. But it's okay. But based on that, they want us to generalize this. So I would give you that information. Here, guys, I'm going to tell you just like this. If you have an equation in this vertex form, that's what that is, vertex form, then h of k is your vertex. That is your vertex, meaning that it's going to be your minimum or maximum. Okay. Here, the k, it tells you to either shift up. This is your shift up or down. Okay. Your vertical transformation or translation. I say translation. Okay. Vertical translations, because it could be left or right. No, not left or right. I mean, up and down. Vertical translation, up and down. Look, I'm about to go to the H. Your H is going to be your horizontal translations. That'll be right or left. And this is your reflection, your vertical stretch or your vertical shrink. And the sign of A tells you whether it's going to open upward or down. Okay? Notice I didn't write it. You can write it. Just continue to read it and follow the instruction. Love you guys. Peace out. Love you.